they're real. So here's what. If I'm asking you the distance between me and the flagpole, and you get like 6 centimeters, that clearly doesn't make any sense, right? These are real. So if you're doing these problems and you're like, she just put a weird answer. I didn't. It means you did it wrong, right? So that's the first thing to keep in mind. Second thing is that this is trigonometry. Your job is to find a damn triangle, right? All of these are going to have triangles. The first two examples I'm going to do are from Algebra 2 and Geometry. Then we're going to move to pre-calc because we step up our game. The first two I did a little drawing for you, right? But then after that, you're going to have to start doing your own drawings. You're looking for a triangle, right? So let's do some vocab real quick. Let's make sure we got some words that we know. We know that anytime they say things like the vertical distance, that is always going to be this up and down line, right? Vertical is always going to be up and down, right? If the problem asks for the horizontal distance, if I wanted to know the distance from dead Noah, the horizontal distance from dead Noah to the balloon, it's this one. That's the horizontal, right? It's the one that normally goes along the ground, right? Horizontal distance. If I want to know the exact distance, like if I was going to shoot someone with an arrow, which will happen at some point, then, or a ninja star, then like if I'm throwing a ninja star at Noah, I want to know that diagonal distance, right? That's the diagonal distance. These are the first few things we need to know. The next two things we need to know is in real life, there are two things you don't want to do out in public because people will make fun of you. Number one, you don't want to stare at the sun, right? And you're thinking, why are you telling me this? Because here's what. If someone, I don't like birds, you're going to see that in a minute. If someone said, oh my God, Mrs. Tarantino, a bird is flying at your face, I would look, I'm looking like this, I'd look up. I'd be like, oh my God, there's a bird flying at my face. Here's what I would not do. I would not look at the bird and then look at the sun. That would be weird. Why would I do that, right? So we don't look at the sun. We don't look out and at the sun. That would be weird. Here's the other thing we don't do. We don't look at our crotches in public, right? It's weird. It's weird. So if someone said, hey, Mrs. Tarantino, there's a bird on the ground, and I think it's going to try to peck your eyes out. I don't do this. I don't look at the bird and then look at my crotch. It would be weird. Why would I do that, right? It means I have a kind of a bird issue, right? I look out and then look down, right? But here's what you all want to do with the angle of depression. So, oh my God, this is going to, oh God, I'm going to get fired right here. Here it is. So here I am. And I'm looking at my friend Noah with the angle of depression. It would be weird if I looked at him and then looked at my crotch, right? I don't want to do that, right? So what I do is I look out and then I look down, right? So please remember this. That's the crotch thing. Don't do that, right? Angle of depression. Don't look all the way down. It's weird. Don't do it. So, the last thing that we got to know is this, is that we can move some stuff around because our goal is just like last night's homework. We're just going to get a little right triangle and find our pieces. But look at this. That stupid 53, that's outside my triangle. Here's my triangle. I mean, you guys can see it. Y'all have it. It's right here. That's a lovely triangle, right? I love that triangle. But I got a 53 on the outside. I need to get that into my triangle. Yeah. It is right now. It is angle of depression is outside. Well, that's my point. So you could do exactly what you're saying. I could make it on the outside, couldn't I? Yes. So Jace just brought up. It's like, well, Miss T, make another triangle and make it on the inside. Perfect. That would totally work, right? Because that's totally fine. The other thing you can do, and again, I say this gently. I'm a trigger warning for you people from geometry. Do you remember when you had angles that looked like this, right? We had parallel lines. Remember alternate interior, this angle, oh my God, I really did trigger you all. This guy was the same as this guy. Here's the Mrs. Tarantino way that's not triggering. The Z trick. The corners of a Z are equal. So look at this. I got a little Z happening here. Do you see it? So I could put the 53 here and do what Jay said, move my line over. Or I could say, hey, put my 53 right there. and then I am good to go. Are you cool with that? Yeah? So here's what I'd like you to do with your neighbors and your calculator. You got a triangle happening. Here it is. There's 53. There is me in the air at 75. I want to know how far it is from me to Noah. That's just old stuff. It's yesterday. That's easy. It's a walk in the park. Do it. See how I can do it. Yeah. That's beautiful. That's going to be fine. So you should have it. Look, I think there's more than you. Oh, no, I mean, it's something. Yeah, because you're right. Didn't work your way. Okay, I'm gonna look at this and say, there's my little alien. It's from where dead Noah is sitting or laying. Opposite and hypotenuse. That is sine. So sine 75 is, oh no, sine 53. Sorry. Woo. Sine 53 is 75 over x. I'm going to do that little flippy thing. X equals 75 over sine 53. Now hold on a second here before we finish this problem. The diagonal is the hypotenuse. It's the longest side. What number should it be bigger than? Yeah, so if you get anything smaller than 75, that's a check for you. You would be amazed how many kids I don't know will be like, ooh, 21, and they'll just put it in. It's like, that's what my calculator gave me. I'm like, your calculator lied to you, right? So double check it. You better be getting an answer bigger than 75. So I am putting this in my beautiful pink calculator. 75 divided by sine of 53. I'm making sure I'm in degrees. I'm getting about 94 feet. Yeah? Does that sound good? Yeah? So 94 feet from me, not degrees, 94 feet from me to the dead Noah. Okay, let's try the next one. Here we go. We got my friend Martin. Sweet Martin. Martin, apparently lies about his athletic stuff. We make fun of him because we don't really like him. And we take his underwear and we put it up a flagpole. So here we go. We're teasing Martin again. It's a problem. They've tied his underwear to the flagpole. Martin is crying because, he's a baby. A big baby. He's very tall. He is 23.5 away from the flagpole. The underwear is flying at the 8.5 meter flagpole. I am looking for the angle of elevation. So Martin is going to do this. He's going to look out and up. I'm looking for this guy. I'm looking for theta. This is a backwards one, right? Our calculator goes backwards on the angle. Nice and easy. Go ahead and do it with your neighbor. Share your answer with your neighbor. See if you're smarter than them. If you're smarter than that, Martin, please make fun of him, because that's always fun. You know what? Even if he gets it right, we'll make fun of him. We'll feed him chocolate until he cries. Opposite over adjacent. We're looking at tan backwards of 8.5 over 23.5 will give us our angle. This is our backwards. Second tan. 8.5 divided by 23.5. Nice and easy. And if you got about 20 degrees, you are awesome. You are awesome. Everybody's feeling okay. Not gonna lie, that's algebra 2. Welcome to pre-calc. We step up our game. I love the next problem. It's hard. It's the I took one of the hardest ones. We're doing it together. So the ones that we're gonna do for homework and stuff are easier. Well, let's see if we can't get a little badass. So here we go. Last one. We got our girl Brooke Johnson. This is true. She likes birds. Birds are horrible. Brooke likes birds. I hate them because they can peck your eyes out, but that's not really important right now. Clearly I write these, and I'm bored. One of Brooks' birds is flying at a constant height of 100 feet in a straight line, and she looks up at the bird at an angle of 70. Now, here's what. If you keep reading this, you're like, what the holy hell? I don't even know what's happening here. I have 2 degrees in here, which means I really have 2 problems. So I want everyone to ignore this part right now. Right? We're just gonna start here. Right? We're just gonna look at this. I want you to do this. I'm gonna make Brooke lay on the ground. I'm not gonna do her height. So first on your board or on your paper, draw Brooke lying on the ground, please. Draw her lying on the ground. Make her pretty. She's pretty. She's pretty. So now make her lay there. There she is. She's laying here. She's contemplating things. She's just having a little rest. She's laying there. But unbeknownst to her, she didn't close the bird's cage. She looks up and she notices a bird has been flying away from her, and she's a little panicked about it. So please, over here, could you draw a bird? Draw a bird. Like make it fly, right? I'm going to put him over here because it's flying away from her. Maybe make it have a really big beak because they'll peck your eyes out, and make it as good as mine. Shut up, that's a bird, and it's a really, really good one. Look, he's got a wing. There, okay, don't judge me. Now he's got 2. There we go. It's a bird, and he's flying. See, notice his wings. Look at his beak. He'll peck your eyes out, right? So, look at this. Do you see that? There is a triangle there. Can you draw me a triangle there? Here's what I'm going to start with. I know I got some diagonal stuff going here, right? I got Brooke, right there, her eye. Let's draw a triangle. I got some height. I know the bird's in the air, right? And I kind of want to know how far that bird is flown right here. Like, how far has it gone? So let's think about what we got there. Look, I got a triangle. I'm pretty excited about it. So I know how high the bird is. Put that on your triangle. He's 100 feet in the air. I also know my angle of elevation from Brooke's eyes. So Brooke was just looking out, and then someone said, Brooke, isn't that your bird? And she looked up, right? That is her angle of elevation. So could you please, with your table mates, tell me how far has the bird flown from here at that point, right? If it was in her hands and it flew up and she's like, look, it's flying, and then it just took off, like how far has it traveled in the beginning of the problem? Figure that out for me, right here. Figure that out. I think some of you are getting what's going to happen in the next part of the problem, right? Because we're going to have a second triangle and do the same thing, and you realize the bird's flown even farther. It looks like it's going to be tangent to me, opposite and adjacent. We use tan a lot in word problems. Go ahead and round to the nearest whole number. It's going to make the problem nice and easy for us. Tan 70 equals 100 over, I don't know. I'm going to get that 100, I don't know. How is it looking? I'm going to put up an answer. Before I do, talk to your neighbor. See if you're going to get the same answer as me. So whisper to your neighbor. It's like, this is what I got. Make sure if you're the neighbor and they get it wrong, please openly make fun of them. It makes math more fun. And 70. Did you get about 36 feet, right? About 36 feet? Okay, so here's what. That bird has gone 36 feet. Well, at this point, Brooke starts crying. She covers her eyes and she cries for 5 seconds. That's really a long time if you think about it. 1001, 1002, 1003. So she cries. And here's what. When she opens her eyes, the situation has changed. So now what happens? We got Brooke. Oh, that's too much Brooke. We got Brooke. We got her bird But now the bird's way the hell over here, right? He's flown farther. And he's still 100 feet in the air. He's still far away from Brooke. But now when she looks at him, it's not 70 anymore. What is it? How many degrees? 35. So here's what I want you to do. I want you to do the exact same thing. Tell me how far the bird has flown total now.
It's casual.
We'll get it. Enjoy it. We're doing the second part because the bird kept flying, right? So we want to know 5 seconds later, now how far away is it? Yes, we're going to subtract, right? Well, because, so which side of we're looking how far is it from? Oh, you might have it. If you did this right here, it's going to be good. Now how far is it from the sun? Yes, you're still doing 10. So we're still doing 10, but it's 1070, right? No, 35 divided by 10. Now watch this. Did you get 1 point or 143? So here's my final question. This is what makes it pre-calc. You guys ready? Watch this. So here's what. When she started, he flew the 36. At the end, he flew 143. How far did he cover in the last 5 seconds? How do I get this the last 5 seconds? What do I do? I subtract it. Does that make sense? Guys, are you with me? I know the total. I just want to know how far he flew just right here. How far was just this? So subtract, take this, subtract that. Have a good time. I'll see you guys tomorrow. They're going to see Lion King. I know. Okay, so here's what. The answers, by the way, this is why we're going to, is minus 36. I got about 107. 107 feet. Okay, I feel like I'm losing you a little bit, so let me tell you what our plan is, Jake. Here we go. So, I am willing to rarely, I hardly ever do this, give you no homework. But I want to do, so here's what. We can't not do, we got to practice these. But I like practicing them together. So here's my goal. I would like you right now, if everyone does this, because we got 10 minutes, if everyone does the first 2 problems with their table mates, Jace, listen, the first 2 problems with their table mates, then we will